The story of Apollo begins not in space but on Earth. In a time of intense global tension, in the 1950s and early 1960s were marked by the space race, a competition between the United States and Soviet Union for superiority in space exploration and technology. The Soviets were leading earlier on with the launch of Sputnik and the first human in space, Yuri Gagarin. In 1960, during the Hoover administration, NASA began planning a follow-up to Project Mercury, a three-person spacecraft designed to support more complex orbital missions. However, it was on May 25, 1961, that the President John F. Kennedy transformed this technical plan into a national mission. Speaking before Congress, he declared that the United States should commit itself to achieving the goal before the decade was out, of landing a man on the moon and returning him safely to Earth. This was a colossal undertaking. The program would eventually cost approximately $28 billion, more than $280 billion in today's money, and employs over 5,000 people, involving work from more than 20,000 companies. Engineering the journey. The biggest challenge was not just building a rocket, but deciding how to get the moon. Several concepts were proposed: building a massive rocket that could fly straight to the moon and land and return, Earth orbital renderers, launching several smaller rockets, assembling the lunar vehicle in orbit, and then traveling to the moon. This was the chosen path championed by NASA's engineer John C. Houbbelt. The Loar method involved a single massive rocket, the Saturn V, launching a spacecraft consisting of two main parts, the command and service module and lunar module. The CSM would carry 3 astronauts to lunar orbit. Then 2 astronauts would descend to the surface in the LEM, while the third stayed in orbit. The LEM would then blast off from the moon, rendezvous and dock with the CSM to return to Earth. The Apollo spacecraft was a 3-part machine. Command module CM, the conical cabin where the crew lived. Service module SM contained fuel, water, oxygen, and electricity for the journey. And lunar module, the Eagle that landed on the moon. It was designed solely for the vacuum of space, meaning it didn't need to be aerodynamic. The rocket that made this possible was the Saturn V, designed under the leadership of Wernher von Braun. It remains one of the most powerful machines ever built. The program faced a devastating setback on January 27, 1967. During a pre-launch test, a cabin fire in Apollo 1 command module killed the astronauts Gus Grissom, Ed White, and Roger Chaffee. This tragically halted the program, causing NASA to redesign the command module completely to make it safer and less flammable. This led to the development of the new material, including flame-resistant Texas. Despite the loss, NASA was not deterred, but rather strengthened its resolve to meet the lunar challenge. Following the redesign, the mission resumed. From Apollo 4 to 5 and 6, these were unmanned tests of the Saturn V and lunar module, providing the system could work in space. Apollo 7, the first manned flight, testing the CSM in orbit, a daring mission that took humans around the moon for the first time. Astronauts Frank Borson, Jim Lovell, and Bill Anders orbited the moon, famously capturing the Earthrise photo. Apollo 9, the first manned flight to test the full stack, including docking the LM in orbit. Apollo 10, May 1969, the dress rehearsal for the landing. The crew flew the LM to within 47,000 feet of the lunar surface. The Eagle has landed. Apollo 11. On July 16, 1969, Apollo 11 launched from Cape Canaveral or Kennedy Space Center. 4 days later, on July 20, 1969, Neil Armstrong and Buzz Aldrin landed the Eagle in the Sea of Tranquility. Armstrong's words, That's one small step for man, one giant leap for mankind, marked the accomplishment of Kennedy's goal, while Michael Collins orbited above. Armstrong and Aldrin spent hours exploring the surface, collecting rocks, and conducting experiments. Following the success of Apollo 11, the program shifted from landing at any cost to scientific exploration. Demonstrated Apollo 12, November 1969, demonstrated precision landing, touching down near the Robotic Surveyor 3 probe. Apollo 13, April 1970. Known as the successful failure, an oxygen tank exploded, forcing the crew to use the LM as a lifeboat to return safety to Earth. Apollo 14, Jan 1971. Alan Shepard, and the first American in space, famously hit 2 golf balls on the moon. These Apollo 15, 16, and 17, 1971 to 1922. These J-type missions featured long stays on the moon and included the lunar rover vehicle, the Moon Buggy. Apollo 17, 1972. The final mission saw geologist Harrison Schmitt become the first professional scientist to walk on the moon, capping off 11 total flights and 12 people walking on the future concepts and the Apollo application program. After the moon landings, NASA insulated the Apollo application program to utilize the remaining hardware. Skylab's 1973 to 1974. The first U.S. space station was built from a modified Saturn V upper stage. It allowed scientists to study the effects of long-term microgravity on the human body, setting the stage for the International Space Station, or ISS. Apollo-Soyuz Test Project, 1975. A joint mission where an American Apollo Command module docked with a Soviet Soyuz capsule in orbit, representing a shift towards international cooperation in space. Technology spin-offs, how Apollo changed Earth. The quest to get the moon required mineralization and new materials, resulting in over 2,000 documented technology or spin-offs that are used in daily life. Computer and electronics. The Apollo guidance computer required the development of integrated circuits to persecute to the modern microchips, fostering the personal computer revolution. Originally named Temper Foam, this was created in 1966 to increase the likelihood of pilots and passengers surviving crashes, now used in mattresses and helmets. Developed by Black & Decker to drill for rock samples on the moon, this technology led to the creation of dust busters and modern cordless drills. Space blankets. Multi-layered reflective insulation made from mylar was designed to protect spacecraft from extreme temperatures, now used in emergency camping and human installation. NASA Digital Image Processing. NASA Jet Propulsion Laboratory, JPL, developed technology to enhance the image of the moon, which was later adapted for the CAT scan and MIRIS. Water purification. Systems created to kill bacteria in Apollo spacecraft are now used in community water systems. Fire-resistant materials. Following the Apollo 1 fire, the turrets and other materials were developed for spacesuits, later utilizing in firefighters' clothing. Scratch-resistant lenses. Helmets, visors, clothing resulted in advanced scratches-resistant clothing for gases. The Apollo program was not just an end, but a beginning. It proved that human beings could leave their home planet and visit another world. The 842 pounds of moon rocks brought back to Earth continue to reveal the history of our solar system. The technology, engineering, and scientific lessons learned during these years laid the foundation for all subsequent human spaceflight, including the space shuttle, the ISS, and current endeavors to return to the moon and go beyond to Mars. Apollo remains a testament to what can be achieved through ingenuity and collective will. Goodbye, and I hope you like this video. And I'm trying to improve by talking a little more slower, but as more as a review, I will make better content. And eventually, I don't have to use scripts anymore. So I might do, because, well, I'm not that smart, but I hope this video was very good for you, and I hope you like and subscribe. And remember, one small step for man, one giant leap for mankind. Anyways, goodbye, like and subscribe, and I'll see you guys later. Bye-bye.